In our last video, we added and subtracted complex numbers. Complex numbers have a real portion and an imaginary portion. Remember, the key to the imaginary portion is just we gave a name to the square root of -1, and what we're going to see is that the math continues to work. We can continue to work as if this thing that we don't see, this strange thing that seems to break the rules of math, if we just treat it as if it can. And so what we do is we call it I as if it's imaginary. Remember, these two things are the exact same thing. This is just an abbreviation instead of writing the square root of -1 all the time. Now, in this video, we're going to multiply the complex numbers. So we're going to start by multiplying it by a constant. So we're just multiplying a complex number by a real number, like 3. Well, it works exactly like you would think. We're going to distribute that 3. He's going to go to the 6, he's going to go to the 2i, and we have our new number. So real simple here, 4 is going to get distributed. He's going to go to the 2, and he's going to go to the 5, and we're going to get 8 plus 20i. Now, same here. You can pause if you want to try it, but it's pretty straightforward. The 1/2 is going to go there and there. So 1/2 times 5 is 5 over 2. 1/2 times -2 is going to be -1. So -1. You don't have to show the 1 if you don't want to. All right, now we're going to multiply two complex numbers together. And what we're going to have to remember is what happens when you multiply an I times an I. That's going to create I squared. It works just like a variable. So x times x would be x squared. Well, I times I is I squared. But remember what I is. It's the square root of -1. So if I were multiplying two square roots times each other, doesn't it then become whatever the number was beneath it? So if I had the square root of 2 times the square root of 2, that's 2. So the square root of -1 times the square root of -1 must be -1. So we're going to need that as we work here. So we're going to FOIL this just like we always would. I'm going to go 4 times 2. It's going to be 8. I'm going to do 4 times this -5i is going to get me -20i. Now 3 is going to get distributed. So we're FOILing this out. That's going to get me 6i. Now here's the new one. 3i times -5i. That's going to get me -15i squared. So we're almost ready to combine like terms, but we have to deal with I squared. I squared, by definition, is going to need to be -1 because it's the square root of what -1 times another square root of -1. So here's what I've got. Well, if that's -1, look what it does. I had -15 and -1. This is going to be turn it into +15. Now, let's combine like terms. I've got numbers here, so I'm going to put those together. I get 23 and -14i, just combining my like terms. And here's my new complex number when I multiply those two together. Okay, let's do it again. Again, pause it if you want to do it yourself and then check with me. I'm going to distribute here. I get 6. I'm going to go there. I get 9i. Go here, I'm going to get -8i. And here I'm going to get -12i squared. Now before we move on, we got to deal with this. Now that's going to be -1. I wouldn't normally probably show it in so many steps here, but we'll do that. That's -1. Now it's -12 and -1, so we're going to tidy that up. We're going to get 6 plus 9i minus 8i plus 12. Okay, now let's combine like terms. We're going to put the real parts together. We get 18. Put the imaginary parts together. I'm just going to write it as I. So we'd have 1i. And there's our answer. Now, an interesting thing happens when we take these exponents further. So we already looked at this. We know I. Well, they're showing us with exponents here. I to the first would always just be I, of course. But we just talked about this. I squared is -1. But look what happens when we go further. I to the third is this, isn't it? I squared times another I. Well, we said I squared is -1. So we start to get some weird things happening. So I I to the first is I to the second makes -1. We saw that. I to the third then would have to make -I, because two of them made -1, and then we had an extra. Now look what happens with I to the fourth. It would make, we just saw that I to the third is -I. So we'd have -I times I. Basically, a better way to do it would be this. I don't like the way they're doing it. Let me show you here. I to the fourth, wouldn't that be I to the second times another I to the second? Isn't that true? Well, I to the second is -1, and I to the second is -1, so this gets back to 1. So one more time. So I to the first makes I to the second -1. I to the third would make -I, and I to the fourth just makes 1. So here's the point. Every fourth power doesn't do anything to a product. It's just 1, so it's essentially irrelevant. And so what we're going to do when we do these higher powers is we're going to see that it continues to cycle. So I don't like the way they broke this up, but so look what I to the fifth would be. I to the fifth is I to the 4 times another I. Well, I to the 4 is always just 1. So every 4 of these i's is totally irrelevant. It just becomes the number 1. So we get back to I. And then I to the 6th is going to do the same thing. I to the 4th times I to the 2nd. All of that is just 1 again. So it gets us I to the 2nd, which we already saw is -1. So it just keeps cycling. Every 4, it just keeps cycling back through there are basically only 4 options. We can get I, we can get -I, I'm forgetting. We can get I, we can get -1, we can get -I and 1. That's it. They're the only options we would get. So look what happens if we do I to the 35th. You go, well, how am I supposed to do that? Well, let's get as close to 35 as we can by dividing by 4. Let me see if I can use what they did. Yeah, okay, this will work. All right, so here's what they're doing here. Yeah, no, I like it better like this. So this isn't very clear. Sorry about that. But I to the 4 to the 8th power, this is 32 of them. Do you agree with this? So if you take a power to a power, we multiply. I to the 4th to the 8th power, that is 32. So all of this, because we've cycled through I to the 4th, all of this is just 1. So every group of 4 creates 1, and we're just kind of looking at the remainder. So I got as close to 35 as I can. That's 32. I to the 32, all of those, because it's divisible by 4, is just 1. And then all I have left is I to the third. So all of these are 1, because that's a number divisible by 4. I to the third is the only thing that's left, and we saw I to the third is -I, which you could reason your way through if you didn't have it memorized. So let's do another one. You can pause it if you want to. I to the 16 and I to the second. 16 is divisible by 4. So all of those, we just keep cycling through, and it still makes 1. It's the same as I to the 4th to the 4th power, but who cares? These make 1, 1 to the 4th. So anytime you have I to a number divisible by 4, it always makes 1. So the only thing left here is I squared, which we've already seen is -1. Okay, now there's not a ton of those either, but so I think that's a pretty clever trick. You're just saying, how close can I get to the number that they have, the exponent they've given to me? How close can I get there with something divisible by 4? In this case, 16 is as close as we can do. This is the remainder. Well, the first 16 just turn into 1, and we're left with I squared, and we know I squared is -1. So I to the first is I to the second is -1, I to the third makes -I, and I to the fourth makes 1. And that's the only ones you ever need to remember, because after that it just keeps cycling over and over.